Section 7.5 is sum and difference formulas. So we can use these sum and difference formulas when angles are being added or subtracted inside a trig function. They also help us find the ratios when we have an angle that's not on the unit circle. So for cosine, we have a cosine sum and difference formula. So if you have two angles being added inside cosine of alpha plus beta, then it's cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. If it's cosine and it's a difference formula, then it's a plus in the middle. So cosine has the same trig function multiplied together, but opposite signs in the middle. So if this is a plus, this is a minus. If this is a minus, this is a plus. So for example, something this would be useful for is if we want to find the cosine of 7 pi over 12. 7 pi over 12 is not on the unit circle, but we can write 7 pi over 12 as a sum of two angles that are on the unit circle. For example, 7 pi over 12 is the same thing as 4 pi over 12 plus 3 pi over 12, which is the same thing if you simplify it down as pi over 3 plus pi over 4. So the cosine of 7 pi over 12 is the same thing as the cosine of pi over 3 plus pi over 4. And I chose those two angles because they're angles on the unit circle. So now I'm going to apply the cosine sum formula that we have up here with our angles pi over 3 and pi over 4. So I applied the cosine sum formula above. So I have two angles added together. So I'm going to have the same trig function multiplied together and then a subtraction in the middle. So I have a plus in the original, so it becomes a minus in the sum formula. So I have the cosine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. And now I'm going to evaluate. Ones from the unit circle that we know. So the cosine of pi over 3 is 1/2. The cosine of pi over 4 is root 2 over 2. The sine of pi over 3 is root 3 over 2. And the sine of pi over 4 is root 2 over 2. So then if you combine like terms, multiply through, you get 1/2 times root 2 over 2 is root 2 over 4. And root 3 over 2 times root 2 over 2 is root 6 over 4. You can't combine the numerators at all, so it just becomes root 2 minus root 6 over 4. So now try the second one, cosine of 165 degrees. So find two angles that you know from the unit circle that you can either add or subtract to be 165, and then apply the cosine sum or difference formula. Sometimes there's more than one way to split these up. I saw 165 as 120 plus 45. So since it's a sum cosine formula, it's going to be the same trig function, opposite sign. So cosine 120 degrees times cosine 45 degrees minus the sine of 120 degrees times the sine of 45 degrees. 120 degrees is in the same place as 2 pi over 3. So the cosine of 120 degrees is negative 1/2, and the sine is root 3 over 2. And then cosine 45 degrees is in the same place as pi over 4, so cosine would be root 2 over 2, and sine would also be root 2 over 2. So you end up with negative root 2 over 4 minus root 6 over 4, or combine the numerators together like that. So on this one we have the sine sum and difference formulas. So on cosine you had the same trig function opposite sine. Sine has opposite trig functions same sign. So the sine of alpha plus beta is the sine of alpha cosine of beta plus cosine alpha sine beta. Similarly with the sine difference formula, opposite trig functions and opposite angles, and then the same sign. So on the previous examples we always split a bigger angle into the sum, or it could be difference, of two different angles that are on the unit circle, but you could also go the other way around. So here we have this one, the sine of 80 degrees times the cosine of 20 degrees minus the cosine of 80 degrees times the sine of 20 degrees. So this looks like the sine difference formula that we have up here. So I'm going to work backwards. I have the sine difference formula and I'm going to change it into this, where alpha is 80 degrees and beta is 20 degrees. So if you work backwards, this ends up being the sine of 80 degrees minus 20 degrees, which is the sine of 60 degrees, and 60 degrees is on the unit circle at root 3 over 2. So remember, equal signs always mean that it's true both directions, so most of the time we're going to go from a one trig function to multiple, but you could also go from the longer version to the one single trig function. Here are the tangent sum and difference formulas. The they're exactly the same. Tangent of alpha plus beta is the tangent of alpha plus the tangent of beta over 1 minus tangent alpha tangent beta. The plus has a plus in the numerator and a minus in the denominator. The difference has a difference in the numerator and a plus in the denominator. So same sign on the top, opposite sign on the bottom. So these are problems that are similar to Chapter 6 problems. We are given a trig function, like the sine of alpha is equal to 4 over 5, and enough information to know what quadrant it's in, and then ask for information about it. Except for now, instead of there just being one angle, there's actually two angles. So we're given two of these, and we want to draw triangles to help us find out our missing information. So go ahead and pause the video and draw your two triangles for alpha and beta, and figure out your missing information. So if you draw your triangle for alpha, they tell us we're in the second quadrant, and sine is y over r, so you have a y coordinate of 4 and a radius of 5, so that means your x coordinate is -3. This beta is in the third quadrant, so again, sine is y over r, that means y is -2 root 5, r is 5, so Pythagorean theorem, you get x to be -√5. So from this information, go ahead and answer at least the first two, the cosine of alpha and the cosine of beta. So looking at the triangle, cosine is x over r, so you have for alpha, you have a -3 over 5, and then for beta, you have a -√5 over 5. So now we want to know what the cosine of alpha plus beta is. So go ahead and pause the video and use the cosine sum formula to evaluate this trig function. So the cosine of alpha plus beta is the cosine alpha cosine beta minus sine alpha sine beta. One thing I really want to stress is you do not know the angles. We don't know what alpha and beta are, and nor do we care. What I'll see a lot of is alpha equals 4 over 5, and then you guys can't find what the cosine of alpha is, or the beta is -2 root 5. No, the cosine of alpha is -3 over 5. So you replace cosine of alpha with -3 over 5, cosine of beta is -√5 over 5, sine of alpha is 4 over 5, and sine of beta is -2 root 5 over 5. So then if you multiply these together, and then you get 3 root 5 over 25, plus 8 root 5 over 25, which is 11 root 5 over 25. So the cosine of alpha plus beta, without knowing what alpha and beta are, we know is 11 root 5 over 25. So this is the sum and difference formula. You will need to know at least the sine and cosine sum and difference formulas by heart. So make sure you have those written down and understand how to use them.